All right, here we are right back at it. We are continuing with complex numbers. That was where we talked yesterday about having imaginary part and a real part, and also just to kind of highlight this, remembering, oops, I made it so you can't read it. Sorry about that. Remembering that I squared is -1, and that if you're taking the square root of a negative, your answer should have an I in it. So we're going to be doing with something that's called the complex conjugate. And basically what that means is you take your complex number and you change the sign before the I part, before the imaginary part. Only that one sign. So if I had 2 plus I, it would become 2 minus I. If I had -3 minus 4I, it would become -3 plus 4I. So you're just changing them one in between. The conjugate's going to help you clean out the bottom from having an I in it, because again, you can't have a square root in the bottom, and since I is the square root of a -1, can't be there. So remind yourself there's no I in the bottom, and then we talked about in the last video that there is never an I squared in your answer. So remind yourself of those two fun facts. The reason you can't have an I squared in your answer is that it's a -1. And so you should replace it with -1. So those are two things you can look for. If you're going to turn in a quiz, you look and you're like, do I have any I squareds in my answers? Because that's not okay. Do I have any I's in the bottom or radicals in the bottom? Because that's not okay. So in this particular problem, I am going to need to get rid of the I on the bottom, so I use the complex conjugate. It's just like what we did with radicals, except it's an I. So just like with radicals, the bottom should clear out and not have any. So when we're done here, the bottom should clear out and not have any I's. Let's do the bottom foiling first. So the first times first is going to be a 9. Then the outside is a +6i, but the inside is a -6i. That should happen all the time. So these two should always come out to be equal but opposite, and therefore ultimately they will cancel out. So that's how you get rid of the i's. Now you have this last term still, which is -2 times +2, so -4, and then I times I. But there is that I squared that you can't have. And if you think of it as being a -1, which it is, it multiplies with the -4 and becomes +4. So what ultimately happens is I get a 13 on the bottom of this, and the I that was problematic is gone. Now I need to FOIL the top. 2 times 3, 6. Outside is 4i. Inside is 3i. What kind of a 4 is that? And then here I end up with 2i squared. But I squared again is a -1. So -1 times 2 makes this whole thing a -2, which can combine with the 6. So 6 minus 2 is 4. And then I have a 4i and a 3i that add up to be a 7i. Now, you can leave it like that, or you can separate them out. But if you leave it all as one, which is probably easier, I call it triangle reducing. You look at the 3 numbers. If something can divide out of all of them, great, divide it out. But if not, then what you have is kind of what you get, and then that is your answer. So over here, I need to get rid of the denominator I, so I'm going to use the conjugate. Whatever you multiply the bottom by, you have to multiply the top by to keep everything in math balance. So here, let's do the top first. So there's a 7. Outside, -28i. Inside, +5i. And last, -20i squared. There it is. You need to change that to a -1. -1 times this -20 makes this entire piece a +20, which can then go back and interact with that other real part, and I get 27. In the middle, these go together. -28 plus 5 is -23i. That's the top, so I'm good with that. What I need to do now is the bottom, and the bottom cannot have an I when I'm done. So 1 times 1, then 1 times negative 4i, then 1 times positive 4i. So not surprisingly, those two cancel as they should with conjugates. And here I have a plus 4 times a minus 4, so negative 16, but it's an I squared. And when you see that I squared, you have to think, okay, that really has a value of negative 1 multiplied by negative 16 means this whole piece is a plus 16 that goes together with the 1 that I had. So I end up with 17 on the bottom. And if I wanted to check, I would do like my triangle reducing, but there isn't anything that goes into 17, 23, and 27. So I'm just done with the 27 minus 23i over 17. Sorry about that. So now you're going to be using imaginary numbers in solving. Keep in mind that not every problem is going to have imaginary numbers just because we know it exists. The only time you need to worry about it is if you have a negative under your radical, you're going to be getting an I in your answer. So we've already solved these before, but now I have that negative. So the root and the x cancel. Here I get my plus minus. I'm going to think of this as a root 9 and a negative 1. So the square root of 9 comes out as a 3, and the square root of negative 1 comes out as an I. And in this case, nothing is stuck underneath the radical. Here I need the x squared alone, so I add 10 to both sides. Now I have x squared equals negative 14. I go to square root, I do my plus minus. Here I get an x, and then over here, 14 doesn't have any perfect squares, but you do have that negative. So you can think of it like square root of 14 times square root of negative 1. The 14 doesn't come out, but the I does, and then the 14 is stuck in here because it doesn't have any factors that are perfect squares. But this comes out as an I. Here I'm going to add my 7 over. Now I have negative 2x squared equals 90. Dividing by negative 2, I end up with negative 45. Throwing down my square root sign, the square cancels with the root. I get plus or minus, and then here, if you look on your blue card, it does break into a 9, which is a perfect square, 5, and then you have that negative 1. So in the end, I get plus or minus. This turns into a 3. This turns into an I, and then the 5 is stuck underneath the radical. So just try not to panic with the i's. It's all going to be kind of the same math we're doing. It's just in that moment when you get the square root of a negative, you're going to have an I in your answer. Or the moment where you have an I squared, you're going to get negative 1. Hope that helps.